everyone, today we are going to see about lemma 2.4.5. There is a one-to-one correspondence between the any two right coset of H and G. So G is a group and H is a subgroup, and the two right coset of H is nothing but the element from A belongs to G, and right coset of a subgroup into that element in G. So HA and HB are some two subgroups we took, that is right coset. So we want to prove that there is a one-to-one correspondence between the two right cosets. So we have to prove that HA and HB has a mapping, that is one-to-one correspondence, that is it contains both one to one function and onto function. So it is known as, so if it contains both one to one and onto, it is known as one to one correspondence. And here I already told that the A belongs to the group, belongs to group. So we take two right cosets, so A and B are the two elements that belongs to the group. Then our right coset are HA and HB are the two right cosets, and for one-to-one correspondence we have to define a mapping that HA to HB. So if an element has here HA, capital HA, here capital HB, here having a small HA, that element of HA, and here also element of HB, then what I told is the function of HA is HB. So it can be written as function of HA can be written as a HB because it is the image of this function of HA. So HA is mapping to HB in the function of F. So only we get F of HA equal to HB. This is one. And where HA, here HA belongs to the capital HA and HB, small hb belongs to the capital of HB. Here capital HA are the right cosets and small HA HB are the element of that right coset. So these are the given, and we have to prove that F is a one-to-one correspondence. That is one-to-one correspondence means F satisfies one-to-one and F satisfy onto. So for example, HA contains, here we have a HA means that map to the HB. So we have H1A means that is mapped to the H1B or something else. So every domain and codomain has a images. So that codomain has a pre-image. So it has all the, if it is HA and it is HB, this is HB, each and every element has a pre-image. So from the question also we know that it is one on two. From one also we get that every function of HA has an some element, or otherwise HB has a some pre-image. So it is on to we proved from the question. Then one more is we have to prove that it satisfies one-to-one. One-to-one function means we already know that f of x equal to f of y, then x equal to y. So here f of h1 a belongs to the equal to f of h2a, that is HA contains in many element HA, H1A, H2A. So we took these two element, that is H1A and H2BA, H2A mapped to the HB, H1B or HB. So if for one-to-one there is only one image. So if it has a one image means this H1A and H2A must be equal. So only we prove that H1A equal to H2B. So we from F is 1-to-1 means we took that H1A equal to H2B, we took this one, and we have to prove that H1A equal to H2B. So we have to consider that from this f of h1a equal to h2b, and f of ha can be written as hb. Likewise also f of h1a can be written as h1b, and f of ha can be written as hb. Likewise also f of h2a can be written as h2b. By using a right cancellation, b and b are getting cancelled each other, and we have h1 equal to h2. We post multiply by a means we get h1a h2a. Then we have proved that if we take f of h1a equal to h2a, and we have to prove that h1a equal to h2a. That is, this is the function of x equal to function of y. We have to prove that x equal to y. Likewise also we took a function of h1a equal to function of h2a, and we proved that h1a equal to h2a. So it satisfies the one-to-one function. From the question also it satisfies the onto. So it is f is 1 to 1 and f is 1 to 1 and onto. So f is 1 to 1 correspondence between that right cosets of h in G. Hope you all understand, and thank you.